Welcome to PIQ'S TV. This is another lesson under General Chemistry 2. This is your host, Dr. Glenn Michael Jameson Pitero. Our topic for today is thermochemistry. We'll explore this fascinating world which is involved in the study of heat related to chemical reactions. Understanding thermochemistry will help you see how energy changes can impact everyday reactions from cooking foods to powering cars. Let's start with some basic concepts in thermochemistry. The most important concepts are enthalpy, or the heat content of a substance, and thermodynamics, the study of energy and transformations. We'll see how this apply to different chemical reactions. There are actually two kinds of reactions related to thermodynamics. The first one is called exothermic reactions where energy is released. The second one is called endothermic reactions where energy is absorbed. For the exothermic, you can imagine lighting a match versus an endothermic reaction, melting an ice cube. How do we measure energy changes? We usually use an equipment called a calorimeter to measure the heat absorbed or released during a chemical reaction. This particular equipment helps us quantify the energy changes and understand the efficiency of different chemical reactions. Let's now have a problem-solving example involving an exothermic reaction. Suppose there are 2 moles of hydrogen gas reacting with 1 mole of oxygen gas, releasing 572 kilojoules of energy. The question is how much energy is released per mole of water formed. So the assumption here, if you can create the balance equation, for every 1 mole of hydrogen, it produces 2 moles of water. So therefore, 4 moles of water are produced. So how can we calculate for the energy per mole? We just have to divide the energy released during the chemical reaction, which is 572 kilojoules divided by the moles of water. That's 143 kilojoules per mole. And how to interpret it? So during the exothermic reaction, wherein hydrogen gas reacts with oxygen to form water, it releases about 143 kilojoules of energy. Let's now consider the other type of reaction called endothermic reaction. This time the decomposition of 2 moles of water into hydrogen and oxygen that involves or requires an input of 572 kilojoules of energy. So that's the amount of energy that will be absorbed since it's an endothermic reaction. How much energy is needed per mole of water decomposed? So it's just 572 kilojoules divided by 2 moles of water. So for every moles of water, for us to be able to form water, it would be 286 kilojoule per mole. This means that about 286 kilojoules of energy is needed to be absorbed to decompose each mole of water. Okay, let's now have a laboratory connected calorimetry problem. Suppose we want to determine the heat release when magnesium burns into the air to form magnesium oxide. So the given are 0.5 grams of magnesium in a calorimeter with 1000 grams of water. Remember, the density of water is 1 gram per ml, so it's the grams and the volume, the mass and the volume are interchangeable here. Calculate the heat absorbed by the water using the formula. Take note of this formula. Q is equal to mc changed in T. M is equals to the mass of water. C is the specific heat of water. So it's C here in chemistry. Specific heat is the meaning of C in chemistry, while in physics it's the speed of light. So it's for the water, it's 4.18 joules per gram degree Celsius. Change in T is just a T final minus the initial, which is 5 minus 0. So 5 degrees Celsius changes in temperature. And lastly, Q is just performing the formula here. Just use the given 1000 grams times the constant 4.18 joules per gram degree Celsius times 5 degrees Celsius. That's about 20,900 joules. So we have to convert this into kilojoules. It's a more common unit in chemistry. 20,000 joules divided by 1000, it would be 20.9 kilojoules. So how to interpret this? 20.9 kilojoules of energy is measured represents the heat released by the magnesium burning with oxygen, which is absorbed by water in the calorimeter. Thermochemistry, in terms of its application, it's not just for laboratories, it's all about us. For example, understanding the energy changes in cooking helps chefs optimize textures and flavors in terms of home economics. In industry, it helps in designing more energy efficient processes. To wrap up our lesson, thermochemistry helps us understand and quantify the energy involved in chemical reactions. This understanding is crucial not only in scientific laboratories but also in many aspects of our daily life and industries. Remember, whether a reaction absorbs or releases energy, it can tell us a lot about the reaction itself. Okay, we are now at the end of our video lesson. Just like our previous video lessons, we have our own exit cards. Just write the things or conclusions about what you have learned about the topic and also what questions are you going to ask the teacher. You can post this in the comment section of our YouTube video. Laging tandaan, sa PIQ'S TV, panalo ang natuto.